Hello everyone, welcome to Data Structure CSS 220 course. This is Sifati Jahan, lecturer from CSE department. I'm going to be one of your instructor in this course, and in our today's topic we are going to learn about a different data structure which is known as linked list. So let's get started. Okay, so before going to jump on what is linked list, let's talk about arrays first. As you have already learned about linear array and circular array in previous lecture, you already know this advantages and this limitation that I am going to talk about. So arrays has some advantages. The first advantage is that an array has it is random access. What I mean by random access? So random access is basically the capacity of a data structure of accessing any data position instantly. For example, if I have an array with 5 elements, accessing the elements in the array, I can do it in a constant time. That means in instantly. For example, I want to access the element in position 2. So what I have to do is just put the array name, and in bracket I have to put 1 to referring to position 2. Okay, if we consider 0 as a position 1. So this is one of the biggest advantages that the array has, which is having a random access. The second advantage is less memory space. Okay, this is basically related with linked list, so we are going to look at this advantage later on this lecture, what I'm referring to less memory space. Now we are going to talk about the limitation that the array has. The first limitation is the fixed capacity. So what I mean the fixed capacity is basically when we declare an array, we have to say what will be the capacity of this array. For example, if the array will hold 5 elements, if the array will have 10 elements, or will have 100 elements, we have to declare it. We cannot have anything beyond the capacity that we define. For example, we have an application where we have to reserve data, and we are using an array. So initially we have like 5 data only, so we create an array of 5 and we store it in the data. As the application don't require any changes, so it's fine. After few months, or let's say few years, the application required to have much more data, that is not only 5, it have to store like 10 data. So for array already created is actually not possible to store it, right? Because the only capacity that the building array has was 5. So what we have to do, we cannot resize it because there is no resizing option. So the solution will be creating a new array of the of size 10, and from the previous array we have to copy those 5 elements. Then the rest of the 5, the new array will have the space for the new data. So this solution is not pretty much a good solution. So this is kind of a limitation of using a fixed size data container. Well, the next limitation that the array has is the shifting requirement when we do insertion or removal operation. So as you already have learned what is shifting when you do insert and remove, this kind of actually disturbing the whole values that are present in the array. Just imagine you have to shift all the elements because you want to insert in position 0. That means all the values that are inside the array have to be shifted once. So this is a very limited issue. So these limitations can be overcome by using a data structure which is known as linked list. Okay, so what is linked list? Linked list is basically a data structure which is made of a set of nodes that are connected via links. So what is basically nodes? We have to understand what is nodes. We can say node is an object that has a data and also has the link of the next node. So a linked list can be presented as a set of nodes. So first node will have the link with the second node. The second node will have link to the third node. The third node will have the link of the fourth node, and so on. So basically, a very simple linked list will have at least a data type, which represent the data that can store, and the address of the next node. You can imagine a linked list as a train. Like we can actually give an example of a real train to visualize how the nodes works. Okay, so let's take a look to this example where we have a train. So if we consider the first one as a bogie, the second one is a bogie, the third one is a bogie. All the bogies have the same capacity of holding passengers. Okay, they can have a lot of passenger, or that can have a lot of extra things, but they have the capacity of containing this. So if you look at the first bogie, the second bogie is connected via some change, right? So the third one is connected to the second one by chains. So if we want to go from one bogie to another, we have to travel the middle one as well. For example, if I want to go to the first bogie to the third bogie, the middle bogie cannot be avoided. I have to pass through the second bogie to reach to the third bogie, right? This is how the train works. Similarly, our linked list works in the same space. That means we cannot access any element at a constant time like in arrays. That is, it does not have random access. It does not have random access. So this is one of the limitations of the linked list, no random access. Even though that it actually does not have any fixed capacity. We don't need to declare the capacity beforehand like arrays. We can add a lot of bogies in the trains, right? Just we have to connect the change and insert a bogie. So this sequence of inserting the bogie and linking with the change works for linked list. We can have a lot of nodes and just we have to connect them to have the linked list. So as in array, we have to declare first that we are going to hold 1000 data or 100 data in linked list we don't need to define any capacity. So the linked list access, as it does not have random access, the access should be sequential. That is, as I said in the example of the train, from going to the first bogie to third bogie I have to travel through second bogie. Okay, so uh, the same sequential access is needed for the linked list. So we start from the first node, then we go to the second node, then we go to the third node, fourth node, and so on. So we cannot reach to the fourth node directly. We have to pass 1, 2, 3, then we are going to the fourth node. Okay, we'll see how we can traverse through the nodes in our next lecture. So for now you have to understand the nodes are connected together and they cannot be reached randomly. We have to follow a sequence to get to the nodes. Okay, so as I have already discussed, the node will have a data contain field. We will have also the link of the next node, so it will require more memory space. It not only have the value as the arrays, it will also have the link. So as it require more memory space to be a structure with which is not fixed sized, and one of the important thing is that as it is has sequential access, we have to know the reference of the first node. The reference of the first node or the starting point in the linked list is known as the head reference. So in this train example, the blue bogie will be our head from where the train starts. Okay, let's look at the memory allocation of the arrays and linked list, how actually the memory is allocated in our computers. So first we have to look at the arrays. Okay, let's consider this example where we have an integer array containing 4 elements. Okay, and let's consider this as a memory space. Whenever we declare an array, the the memory that the computer allocates is always in should be contiguous space. That means the 4 values that the array will hold will be in contiguous space. So this orange color field, let's say if the computer gave us this memory, this is a valid representation of a memory allocation of an array. The second orange one is also valid. Any contiguous 4 space is valid. However, if you look at this green one, we have some here and we have some here. This is not contiguous space, so this is not correct memory allocation. This is not correct memory allocation because this is not contiguous. So for array to be declared to be represented in the memory, always should be contiguous. What about linked list? Let's consider this linked list where we have 4 elements. Okay, A, B, C, and D. This A is a node. This B is another node. This C is another node. This D is another node, and this signs representing the end of the list, or we can call it a null reference. Here we have the first node reference as the head. So how these are represented in memory? As we already know, these are objects, and objects has dynamic allocation in the memory. So let's look at the memory allocation. Okay, here is the memory allocation. We can have A here, then we have B here, which is not contiguous. Then we can have, let's say, C here and D here. So basically it means the memory can be allocated anywhere in the linked list. So in the chain we are going to have these representations. We have to hold the address there. Okay, so the last thing that I want to show you in this lecture is the node class, how we can write the node class in Java. For example, this is a very simple node class where we have an object element. This object element is the data field that I'm talking about when we are referring to the data field in the linked list diagram. Then we have the next, which has the type node. This is basically an address of the next node that we are going to save, so the data type must be another node. And then we have a simple constructor here where we are having an parameter e and n for the object value and for the next address. Okay, so remember this class, we are going to use it in our next lectures to explain how we can work with the linked list. Okay, so that's all. Thank you.